Students, in this video we are going to see about program and network properties, which includes data and resource dependence. So in the PPT we have seen about the theoretical explanations of each dependence. Now we will see with one example. So as we know that this data dependence divided into 5 types. One is flow dependence, second one is anti-dependence, and third one is output dependence, and fourth one is IO dependence, and last one is unknown dependence. So let me move on to the first one, flow dependence. Flow dependence is defined as say for example, if you take two statements S1 and S2, means if any one of the outputs of S1 depends as a input to S2, means these two statements are having flow dependence. So I am repeating, any one of the output of S1 is given as input to the statement of S2, means this S1 and S2 are having flow dependence. It is represented by one directed arrow mark line. Okay, so it is represented by one directed arrow mark line. So this is called as flow dependence. And second one is anti-dependence. Here it is represented by the same how we represent in flow dependence, with one line in the middle. So what is the difference between this S1 anti-dependence means here S1 and S2 will not be related. So here the output of S1 and S2 will not be related. So that's what it is named as anti-dependence. And then coming to third one, output dependence. Output dependence are like S1 and S2 are the two statements, means here output dependence produces the same output variable. If the two statement S1 and S2 are the two statement, it produces the same output variable, means that kind of dependence are called as output dependence. How it is represented means, first it starts with one circle, then directed edge arrow mark line. Okay, so this is the representations of output dependence. And fourth one is IO dependence. If any of the statements involve the read statement and write, load, store, so those kind of executions are coming under the category of IO dependence. And last one is unknown dependence. Say for example, if you are working with loop, say for loop or a while loop, if you are working with some loop situation, that time the subscript of a variable is not known. So it may be floating values. So that kind of dependence are called as unknown dependence. Okay, so this is the definition of dependence, data dependence in this category. With this knowledge, now we are going to write one dependence graph. We are going to draw a dependence graph. For that, I have taken an example is S1 load R1 comma R1 comma A. That means the memory accumulator value is stored in the register R1. Then statement S2 add R2 comma R1. That means addition of values in R1 register and R2 register is added and it is stored in the register R2. And statement S3 states that move R1 comma R3. That means the value of R3 is moved to R1. Then statement S4 states that store B comma R1. That means B register, memory of B register value is referenced by R1. That means the value of R1 is stored in the memory B. So this is the 4 different statements given for this example. With these 4 statements, we are going to draw a dependence graph. How to draw? First you mark each statements S1, S2, S3, S4 and put a circle over there. So S1 is covered with one circle, S2 is covered with one circle, S3, S4, and this is the initial step. Now we move on to each statement. First S1 and S2. S1, S2 is having any relation or not. How we can relate that? We know that the dependence meanings. So any in output of S1 is related to S2 or not. Here we know that the output of R, what is the output of statement S1? R1. So R1 is given to the statement in S2. So the output of R1 is given as input of S2. So now we can say that S1 and S2 are having flow dependence. So how we can write? Here flow dependences will be represented like one directed edge arrow mark. So here I can write like this. So now I found one dependence. So S2 is having flow dependence with S1. Okay. Then coming to S2, S1 and S3. We must compare each one. S1 is compared with S2. Then we must find the dependence between S1 and S3. S1 is nothing but load R1, A. Right? Then S3 is nothing but move R1, R3. We know that any of the read statement, write statement, load statements and store statements involved in your execution means that kind of statements are having IO dependence. So that kind of statements are having IO dependence. So now I am writing this one. S1, S3. Okay. So that kind of dependence are having IO dependence. Then next S1 and S3, S4, S1 and S4. S1 and S4 load store statements are same. Load and store statements are there. So here we can write this one. The same thing. Then next we are comparing S2 with S3. Already S1 and S2 compared. S2 with S3 is compared. S2 and S3, when you see add R2, R1, move R1, R3. So here there is no differences between, there is no relation between these two statements. So here R2 and S2 and S3 is having any overlapping in that. So we can write these two are having anti-dependence. Then S2 and S4 is this is also don't have any relation. We can leave it. Then S3 and S4 move and store. We know that move and store R1 and R2. That output of this R1 is given as input. So output of one S3 statement is given as a input. So here we can say that S3 and S4 is having flow dependence. Okay. So likewise we can draw a dependence graph. So this is a dependence graph for this particular set of statements. Here I am once again repeating, S1 is having one execution, S2 is having one execution, S3 is having one execution, S4 is having one execution. So now when you are going to draw a dependence graph, first you mark all statements in a circle wise, S1, S2, S3, S4. Then you start comparing the first statement with another statement. If any dependence occurs, you can draw like that, flow dependence or anti-dependence or like that. Then you can continuously compare the first statement with the rest of statements. If any of the dependence occur, you can draw, or else you can leave it. So similar way you can start with comparing the second statement. Likewise you can complete the dependence graph for the above set of statements. So this is the way of writing one dependence graph. I hope you understand this one, because this is the initial prerequisite for the next condition, the next type of condition called Bernstein condition. So Bernstein is one of the author. He developed one set of equations to find out whether that execution of this program code has achieved parallelism. If it is achieved parallelism, means how many way of that parallelism is achieved. So this is one example of prerequisite of going to find out the conditions of parallelism according to the Bernstein equation. I hope you understand this video. I'll catch you in the next video about next topic. Thank you.